Okay, in today's video, I'm going to show you how to go from the empirical formula to the molecular formula for a compound. And just to review really quick, the empirical formula shows you the lowest whole number ratio of elements in a compound, and the molecular formula shows you the actual whole number ratio of elements in a compound. I just think of the empirical formula as the reduced form of the molecular formula, kind of like you reduce a fraction, but it's the reduced form. All right, let's go through and see if we can do a couple of problems here. We even says here, what is the molecular mass of the compound? What is the molecular formula, what is the molecular formula of the compound below? Here we've been given the empirical formula, and here we've been given the molar mass. You need to remember that this molar mass that you're given is the molar mass for the molecular formula. You need to have that. So I'm going to write down here M for molar mass, that's the molar mass of the molecular formula, and I'm going to compare that to the mass for the empirical formula. So I'm going to write down empirical mass. That's how I'm going to abbreviate that. Okay, and then we can see the ratio of those two. So we know that the molar mass is 90. That's what we've been given. Okay, and we need to figure out what the mass is of the empirical formula. Okay, so we have two oxygens is 16, 16 is 32, plus 12 is going to be 32, it's going to be 44, and then plus one hydrogen is 45. So we know that the mass of the empirical formula is 45 grams per mole. Okay, and then I'm going to divide those out, and obviously I'm going to get 2. Okay, now what does that 2 tell us? That 2 tells us that in our molecular formula, there are 2 empirical formula units. So to get the molecular formula, because I know there's 2 empirical formulas inside that molecular formula, essentially I'm going to take my empirical formula and I'm going to take that empirical formula and I'm going to multiply it by 2. And if I multiply that formula by 2, I do that like this. I get H2 C2O4. That is my molecular formula. And I know that that's the molecular formula because I compared the molar mass for the molecular formula to the molar mass for the empirical formula. I found out that the molar mass for the molecular formula is twice as big. That tells me that there's 2 empirical formulas in one molecular formula. So I just took my empirical formula, multiplied it by 2, and I got my molecular formula. That happens to be the compound oxalic acid. All right, let's go and do another one here. Once again, we've been given the empirical formula, the molar mass for the molecular formula, and we want to know what is the molecular formula for this compound. So we're just going to do the same process. We're going to take the molar mass, we're going to divide it by the empirical mass, and I'm going to put up here, because this is what I've been given, 150 grams per mole. I'm going to divide that by the empirical mass, and the empirical mass in this case is going to be 1 carbon, 2 hydrogens, and an oxygen, and that adds up to, let's see, 12 and 16 is 28, plus 2 is 30. So this is 30 grams per mole, and that means that this is going to be 5, which that tells me that I have 5 empirical formulas in my molecular formula. So I'm going to take CH2O, and as I did before, I'm going to multiply that by 5, and that is going to give me C5H, 2 times 5 is 10, and then oxygen 1 times 5 is 5, and that is the molecular formula for a compound that has this empirical formula and this molar mass. And that is the formula ribose, that's the compound ribose, which is a simple sugar, a monosaccharide. Okay? All right, let's get rid of that, and let's see if we can do one more. Okay, now we have the same thing. We want to know the molecular formula. We have the empirical formula, NH2Cl, and we've been given the molar mass. We need to remember that's the mass for the molecular formula. So I'm going to put down M for molar mass, molecular formula, and I'm going to compare that to my empirical mass. And this is 51 1.5 grams per mole. I'm going to divide that by the empirical mass. And if we do that, you will notice we get, let's see, 1 nitrogen is 14, 2 hydrogens is 2, so that makes 16, plus my chlorine is 35 and a half, and that makes a total of 51.5. So you'll notice that the empirical formula mass is the same. And that means that this is 1. And that means that the empirical formula, that basically means that in the molecular formula, there are 1 empirical formula units, and that means that the empirical formula and the molecular formula are the same. If you compare the masses of the two and you get an answer of 1, then you know that the molecular formula is the same. So obviously the molecular formula is just NH2Cl. Okay, so that is the molecular formula for the compound that has this empirical formula and this molar mass, and that is the compound that we call chloramine. Okay, so I think that's relatively straightforward. It's not that many steps. Try that, and I think you'll be successful. Thanks for watching, and we will see you next time.